Okay, so we've been looking at the t-distribution, and now we're going to take a look at the t-test. And you might actually, when you run through these snippets of code, just check the HTML for a fuller explanation, and likewise here as well, check the HTML. In this instance goes to another YouTube video, not mine, but a very colorful and animated explanation of what's going on. I'm basically going to take this R code, I'll set it up in the R Studio, we'll run it, and the rationale for using this code is just to observe how we might implement a t-test where we're testing the difference between two means. We want to verify that two populations or two samples are different. Okay, so to run that, we'll go File, New, R Script, with a blank canvas. We'll paste that code in. I might just delete the previous code, so clear the console, clear here the global environment, and in addition we'll clean out the graphs. And we're going to use if you don't have the gap finder dataset, it is downloadable from the CRAN repository. I already have it installed, so I won't install again. But to make that data set available here in our environment, I'll go Library Gapminder. So we load it in, and then the data Gapminder we attach, and we can summarize that Gapminder. Okay, so we have these headings, right, and it gives us just the descriptive statistics, but we could also just take a look here and we can see better a sense of what's going on. So we basically have every country in the world, okay, going from A to Z, so down to Zimbabwe, and then we break that down for each continent. So every country belongs to a particular continent. Albania belongs to Europe. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 observations, 12 years. Every 5 years would appear we have measures for life expectancy, population, and then GDP per capita. Okay, so okay, now of course the data set here is huge, and what we plan to do is take observations for France and for South Africa, and then have a look at the life expectancy, take the mean of the life expectancy, and pose the question, are the means different or the same? So in a statistical sense, do we have evidence to support the hypothesis that the means are equal? That might be the null to be set up. If not, then the same. Okay, so let's go back into our code for a moment. Right, so we have we can set up an object and just take out life expectancy. So let's run that and take a look at the life expectancy. So the mean of life expectancy is 59.47. So that's for all countries for all years. It doesn't tell us a huge amount. What about the distribution? We could use a histogram, and we can see that life expectancy in some countries can be very low. Then there's a kind of a plateau, and then in a number of countries we reach close to in excess of 70 years and beyond 80, right? So that's the distribution of. So for a number of years in a number of countries, life expectancy has exceeded 80 years in some jurisdictions, but in many years life expectancy was much less. And of course, war, disease, poverty, GDP per capita, all these have effects, right? Okay, let's do a box plot, and we will examine life expectancy broken down per continent. So we have a box plot for each continent. Africa, with some outliers, has the lowest median. Then Asia, and there's quite a degree of variation here. The Americas, so that's North America and South America, Europe, and then Oceania, right? Seems to come out best. Europe also looks good, but quite a few outliers. Okay, so to organize the data, then we'll use the dplyr library, which is from tidyverse, and I have that already installed in the machine, so this is quite good for data transformation and for data query. We'll select then countries, so we'll try to pull out of the global database over the 12 years spanning, I think, 1950s up to the 2000s. We'll pull out two specific countries, France and South Africa. Now we can use the dplyr grammar syntax to select the country life expectancy. So if we go back into here, we have country. We can select this column and then select the column for life expectancy, and then from those columns we select filter the country into South Africa and France. Okay, so and then summarize the create a variable average life and estimate the mean life expectancy for South Africa and France. Okay, so we run that. We get a mean life expectancy of 74.3 years, and for South Africa 54.0. Again, if you like, we create it, in effect, if we turn this into an object, so just put a narrow sign, point it at a new variable name. So if I run the same snippet of code again, but in this instance, just filter the relevant subset of data, give it the variable name, the vector name df life, so the data frame for life expectancy. And what we have then is France and South Africa. Let's view that. And what we've done is we've moved from the entire data set, and we have queried and subsetted it down using the dplyr syntax, so that we have France, 12 observations of France for varying years going up, I think, to 2007, and then likewise South Africa from the 1950s up to 2007. And we can see here with South Africa, life expectancy rose and then it tilted back again, whereas in France the life expectancy in the post-war years quite low, but improvements have been made and life expectancy up to almost 81 years in the final, when we looked at it in the final year. Now in the global, keep in mind as well, we go from 1952 up to 2007 in steps of 5 years. And what we would like to do is to check, are the means, can we state with statistical, can we be emphatic and say that the life expectancy is different in both jurisdictions, or is it the same? Okay, so we run the t-test here, which is a function in base R, and our data is this object that we created, and then we want to compare the life expectancy, right, in both countries. So basically we're taking the mean of the life expectancy and comparing, and then we're trying to say, are they statistically different from each other or not? Okay, so we run that, and what we have, we start off with the null, that the life expectancy is the same in both countries, but what we find is that the p-value in that is so low, it's virtually zero, that we can dismiss the null, and we find that the difference, there is a difference in the life expectancy, And we can construct a 95% confidence interval to predict that differences in the mean, and it would be between 16 and 24 years, the differences in the respective means, okay, with that level of confidence. Okay, so that's the T, an example then of the T distribution, and a test then, a t-test that is commonly invoked to verify, are the means of two samples similar, or can we say they are different?